All right, everyone. So this is our introduction to Spark Machine Learning Libraries lecture. And here's the agenda. Well, brief overview of new skills you're getting, some key reminders for assignment 2, the markdown for Jupyter Notebook, then very important to understand parser function because this is where most of the errors for this assignment happens. Well, we're going to talk in general tips for part 2, and I'm going to give you another example, logistic regression model for Fahrenheit data. Then there are some additional plots that you're going to see. It's not something that you're required to do in your assignment, no, but this is something that I want you to work away with. I want you to have an example, okay? Now, what new skills you're getting here? You're learning to integrate multiple skills in the role of data scientist. You learn how to manage data management. You learn how to work in the clouds, including its benefits, right? And you learn how to manage resources. So you may have noticed that, right? And I've been talking about it. You have 10 hours per month, 10 capacity hours. So not 10 clock hours, 10 capacity. The environment takes 1.5 capacity hours per actual clock hour, right? So your task is to use these hours wisely and still do the work, right? Not doing the work is not using the hours wisely, okay? So remember that. So please do not enter the credit card number. This is not going to give you more hours. This is not going to solve any code errors. So please don't do that. Remember that, okay? Now, important reminders, please do not upgrade your account. You need to stop the runtime environment because exiting, because it's going to consume the hours. Closing the browser does not stop the environment. Deleting the notebook might not stop the environment. Deleting the project might not stop the environment, all right? You must stop the kernel before you exit the notebook, okay? Because if you don't stop and you're still sitting in a notebook, you might not be able to stop the environment from manage runtime page. So you have to stop in a notebook and you have to leave the notebook, okay? Please do not open tickets with IBM. They're not going to solve your assignment. You want to submit the Salesforce ticket for assistance. Then if I give a proposed solution, you need to always respond, okay? Because if there is no response for 48 hours, your ticket will be closed. Then you have to upload data to the project before you are creating the notebook. Please do not delete object storage. And another thing is you don't want to open two notebooks in a edit mode at the same time, and do not open the same notebook in the two browsers or two browser tab, because what's going to happen is you might end up running the runtime twice, consuming the hours twice. Please, when you run the notebook, it's important not to skip cells. You have to run everything, the whole notebook, starting from the top, okay? You cannot just go ahead and quit, you know what I'm saying? Now, remember the correct runtime environment. Well, you can choose default Spark 3.4 or 3.3. It's the same. Well, it's the code runs in both environments without making change. So you can choose 3.3 or 3.4. This time you're lucky. But still beware, if for some unknown reason you don't do this assignment, and if you got an incomplete after semester ends to complete the assignment, there is no guarantee that you're going to have any of these two environments, because the system keeps on updating a lot, right? You never know. Maybe there could be next version of Python, or there could be next version of Spark, right? So please try to do this on time. Okay. So now I'm going to show you a little bit about the Markdown cell system syntax. You may or not have noticed that you have level 1 heading in a notebook. You have level 2 headings. So level 1 headings, they have a 1 hash mark. Let's go to the notebook, actual notebook to see it. And the thing is with that thing on top, sometimes, okay, here it is, right? So now I don't have anything running, right? I was checking before this. Okay, now what I'll do, I'm gonna go to the project, right? And I go to the projects, view all projects, and I'm gonna go to my Titanic notebook, which I uploaded. That's a sprint demo. And I uploaded this notebook in here, right? And unfortunately, I'll have to go in the edit mode to show you the code. But see, I'm gonna click on edit and I'm gonna show you what's going on in here. So here it is, open. So if I double click here, see this? Okay, so this is heading level 1. It has a 1 hash mark followed by the text. See, the format is a markdown. Format of the cell is markdown. So how do I go back to it showing the actual header? I run the cell. See, then it will show the actual heading. But this is just the code, 1 hash mark. So this is what table of contents. This is the level 2 headings, right? So see this double hash mark. What is this? This menu is nothing but bulleted list of items, right? It's a bulleted list of items, and each item is a link to the location inside of the notebook. So how do we do this? This is a double hash mark, and this is what? First of all, the bulleted point is dot, right? So this little here means that the bulleted point is a dot. Then next thing here in the brackets, it means that it's a link. Here is a link anchor. Where does the link take you? There is a location in the notebook called Titanic data. So if I double click here, see this? This is an anchor, right? So this is location, the ID is Titanic data. So clicking on that link is gonna take you to here, okay? It's gonna take you here. Now, what else is in here? So those are the links, right? And the bullet points. And each link has an anchor where the link takes you, right? So this is a location Titanic data in the program. And there is also location load libraries in the program, in the notebook, sorry. So it's gonna take you here. The link is gonna take you here, see? Load libraries. Now, this paragraph here has a link to external source, right? So this is just the external web page that is the source of this data, okay? Now, what is this here? This is a table, right? So to do table, you can write the HTML code. Well, you don't need to know HTML, but this is just showing you how this is done. See, HTML, the opening tag is table. This is the opening tag because it means that the table starts. And this is the closing tag, right? End of the table. Each table consists of rows, and each row consists of the cell, table data itself. So this is a table row, right? This is the first row. And the first row contains how many cells? 1, 2, 3, 4, right? 4 cells. Okay, so the first cell is just a blank, nothing in it. Next cell in the first row contains this variable, right? The next cell contains this description, right? Then in the last cell, what I want to do is I want to show the picture, but I want this picture to span 7 rows, right? So that's what it shows, row span 7. And it means that in the next row, you're gonna have 1 cell less, right? Because this cell is spanning multiple rows. See? Then you describe what each column is, right? Because that's what it is, and this is just the font size and the text alignment. That's what, so I'm just gonna do, if I do run, it's going to show me how the table looks like. This picture spans the whole thing here. Then for the picture itself, you need to specify the link. You cannot copy and paste the picture in here. Well, but see this is how you do it, image source. And this is a location it's the URL where this picture is located. So just specify this URL, okay? That's for this picture here. I hope it makes sense, right? So now, well, I have to stop the kernel to make sure I'm not doing anything here. Okay, now, well, this was just the HTML thing, and I showed you that, right? I explained how this is set up, because you will need to do, you're required to do the table of contents, but what you can do is you copy the tables that you're given, right? And you may need some adjustments for your data for part 2, right? Another thing is, well, this is extremely important, and I cannot stress how important it is. Parsing data. So basically, what's happening is this. You are reading the data from the CSV file, right? So you pass the one row at a time through the parser function. Because see, the functions that you need to run, the logistic regression, they take a set of labeled documents. So you have to parse each row into the set of in the labeled document, and you need to skip the first row. How do we know that it's the first row? The first row contains column headers, okay? The first row contains column headers, so we know that one of the cells contains this word name, right? So this here, it calls the parser function that you defined, and it's gonna omit the first row with column headers. That's what it does, okay? So, but let's look closely what the parser function does, because this is extremely important to get it right for your assignment. Well, what is doing? First of all, you want to make do yourself a favor, big favor. List all those columns like this and put their position. The positioning starts from 0 in Python. Also, first column in the data set is name, it's in position 0. P class, it's in position 1, age in position 2, sex in position 3. Birth of the person is survived, position 4, and this is personalized position 5. First of all, somebody's name needs to be skipped from analysis because it's a PII, personal identifying information. It does not help the algorithm, and we just don't use it, right? Things like if you have credit card number, social security number, somebody's name, it needs to be omitted from analysis, right? So next thing is this. Remember, we have to define the label document, right? Because that's what it takes as an input. The method takes a set of label documents. A label document consists of 3 parts. First part, called person ID. This is the unique row identifier, right? So that's this column here. Person info is a concatenated list of the columns that are used as predictors. Labeled is a target column, but it has to be like either 1.0. The value needs to be either 1.0 or 0.0 because this is a regression, right? The target can have 2 values, 1.0 or 0.0. What is it doing in here? It's checking if the column in the fourth position, right? Jesus survived in the fourth position. If it's greater than 0, then it's gonna be the 1.0, right? It's defining the variable called defining survive. Survive is 1.0. Otherwise, survive is 0.0, right? So next thing is building the delimited list of predictors. What are we using? We are using P class, we are using age and sex. They're in positions 1, 2, and 3. So that's what it's doing. The space delimited list. What do we return? Values of 5. This is the identifier. This one is a delimited. It's the delimited list of columns that you use to predict whether the person is survived. And survive is here. You defined it. It's either it's 1.0 or 0.0. Okay. Very important. You will need to edit this function for your assignment, because if you do not, if you plug it in as is, you're not going to be using all columns, and you're going to be predicting, believe it or not, if mother is a smoker, which is not the purpose of the part 2 data set. All right. So please be careful, because if you don't do it right, you're not using all columns, you're predicting the wrong column, and all of your analysis will be incorrect. Okay? So this is here. This is a parser function definition. And if you scroll down, there is a location where you're calling that parser. See, I'm not going to run everything for you, but I ran a little bit. But see, here as you're reading and you're outputting the first 5 rows, right? Then you're splitting data. It's here. Well, see this, you're calling it here. See this? You are omitting the row that contains this text name, because it's a row with column headers. Then, very important, you want to output 5 rows. And you want to check if the first row in your output contains column headers, it means that you did something incorrectly and you did not remove column headers. You need to edit this line, because there is no column called name in the part 2 data. Okay? Well, then you split data into training and test, and you evaluate the model. I ran just first few cells in here, but again, it's your assignment. I don't want to do it on your behalf, right? Okay? But see this one? See? This is how you make it look nice. You just run it. Okay? I'm not going to rerun all of it. I just ran that. Now, if to exit, well, first of all, you want to do this. You want to stop kernel. I stop my kernel. Then I go back here, leave, right? I leave this notebook. Then I need to go back here, right? Clicking on the navigation menu. That's an environmental runtime. And I want to make sure that I don't have anything in here. I'll see this month I used this so far. And this is what I have left so far. For your part 1, I do not expect you to use more than a 1 capacity unit, because the only thing that you are asked to do in there is to add credential block and to change the word bucket with the bucket name. That's the only line of code. Everything else you just run and you save the notebook as HTML, okay? But there is not really much to do. You just need to study and understand the code, okay? Also, that was parsing data, right? This is I just talked to you about the custom parser function. So make sure that you do not delete this word label. You don't rename it. It has to be label, okay? Otherwise, it won't work. Okay, so here the error just shows you what goes where. You need to do yourself a favor. List those columns like this, okay? It will be much easier. Okay. This is just showing you need to split data into training and test set. The example is doing it 0.8 and 0.2, so 80% and 20%. You may want to try 70 or 30 if you'd like. But remember, in the past courses you did 70 and 30, you can try that too. Okay? If you want to, you can change it, but this is just showing you how it is. Party tips, additional, when you read the data, you want to make sure that you add this line in for schema, because if you don't add this line, your analysis for H column will be incorrect. You want to make sure that Age column is red with correct data type, which is numeric, right? Then when you run analysis to do the descriptive statistics, you want to make sure that you're looking at the actual value and you're not looking at the ASCII value of the page, all right? So remember, you cannot plug in just Spark2 data into Titanic code without editing, because you're going to be analyzing if mother is a smoker instead of analyzing the lowest birth weight, right? Okay. I'm going to show you another example today, and it's called the Framingham data. We build logistic regression model to predict if the patient is at risk of coronary heart disease. Well, in this case, you have 17 columns, but remember, positioning starts from 0. The first column at position 0 is the row ID, which is patient ID. Here, the last column is we are predicting if the person has a 10-year risk of coronary heart disease, right? So I'm going to open this notebook right now, and I'm going to open that notebook in the edit mode. So I'm going to go to navigation menu, view all projects, and I'm going to find my project. This is a Spark demo. I'm going to click here. Now what I'll do, this is the Framingham data. I'm clicking here and I'm going to go to the view, right? Well, what does it do? I can preview the notebook here. Okay. Now what? Look here, this is just the heading, right? This is my table of contents. And when I click on each section, right, I click here, explore data, it's going to take me to data exploration section, right? So, well, what is this? This is again the HTML part. Well, see, it's just, well, it's doing it's a table. So I was able to reuse the HTML code, just had to add more rows. This is what you cannot copy and paste the pictures. So this is a link to the picture somewhere on the web, right? I listed all my columns here and added the explanation. Here, I'm loading the libraries in here, right? The libraries that I need to use for this, for the code below. What is this? This is my parser function. I did myself a favor. I listed all the columns here and their position. See, position 0 is going to be the patient ID. This is the ID that gets passed into the label document. Person info is a concatenation of all of the columns. But here, what I did was I tried multiple combinations, because there are a lot of columns, but if you can see, some columns are collinear. Well, for example, there is a column that tracks if the person is a smoker, and another column tracks the number of cigarettes per day. So probably if someone is a smoker, they're going to be more than 0 cigarettes per day, right? So those two columns are kind of like dependent on each other. I probably want to keep either one or the other, right? But first, what you would do, you would first run with all columns, and then you could start playing around with combinations. But see here, what I'm doing, the last column at position 16, it's a target, so I'm checking if it's greater than 0, then it's 1.0, otherwise it's 0.0. And see here, it's passed here. This one is the position of the ID, right? And that's the limited list of columns. Why I did not copy and paste the code from Titanic data directly? Because otherwise I would be predicting somebody's education, right? Because this is at position 3, somebody's education. See, I don't want to be predicting wrong columns, right? I want to be predicting if the person has a 10-year risk. of coronary heart disease. What's the whole purpose of this? So here, this is just a parser, right? And I will have to call that function, but remember, there is no column called name. So I have to do something different where I am eliminating the first row with column heading. So I'll scroll down. It's in here. See this? I had to change this to person info. And the reason is I have to change it, well, because there is no column called name. There is a column name called person info. And I wanted to remove, right? Oops, sorry. It has to be up. It's up somewhere. This is building logistic model. It's up. So what I had to do is I had to remove the person ID rather, right? So let's go up here, patient ID. Well, this is patient ID. This is a column, right? So I had to remove the column patient ID. Well, I have to remove the row that contains the word patient ID. I'm not removing the column, I'm removing the row. But how do you identify that row? One of the cells has this text, patient ID, right? Now I'm calling the parse document function that I just talked about. Here is just creating the data frame. Well, over here, this is your check. Well, what is the check? If you see the column names in the first row, it means that you're not removing the first row, right? You need to remove the first row with column labels because you don't want to treat the column labels as data. Then you're going to split data. See here, it's similar. Splitting data into the training and test. In here, I'm using 70% and 30%. Okay? Then I output number of how many rows are training set, how many rows are in test set, and that's the first 20 rows in the training set. Next thing, you're gonna build the model, and you're gonna you do prediction, right? You basically, you need to build the model for the training data, then you're gonna apply that model to the test data, right? So those are the predictions. Well, this is a dense vector. So the first value, it shows you the probability that there is no risk, right? And the second value, the probability that there is risk. It shows the probability of each value of the prediction, right? The target. So in here, the prediction is 0 because the value 0 has a higher probability than the value 1. Here, the prediction is 1 because the value of 1 has a higher probability than the value of 0, see? So you pick the one that has the highest probability. And see that this data set is a little bit imbalanced too, right? So you have, this is just the output for the first rows. Then what you do, this is not the confusion matrix that you're used to, but it's just a cross tabulation. I want to see how many patients, how many you have actual predicted as 0, how many predicted as 0, how many predicted as 1, right? And you may want to look sometimes at you tabulate the actual, the predicted outcome, and you tabulate the actual outcome. That's what it's doing in here. Then you try to look at the cross tabulation versus like actual label and the prediction, right? Then you just evaluate the model. Another check in here. The area under the RAC curve, it must be at all times, it must be between 0.5 and 1. If you see area under the RAC curve as 0.4, it means that you need to go back to the drawing board. Something wrong. Maybe your parser function is wrong. Maybe you're not splitting the data correctly. Maybe you didn't remove the column names. Anything could happen. You need to go back and check, right? Then you got the rock curve plot. Oops, what am I doing? You got the rock curve plot here. Okay. Well, another thing that I did for you here, I did some advanced visualizations, as you may have noticed. Well, this is just the Explorer data, right? Print schema. Then this is just showing the number of patients, but I did advanced explorations. Uh, well, this is not advanced. You have seen this chart, right? You have seen this, but what you have not seen is this one, maybe. That's a, oh, you may, okay. This is just showing you the data frame information, but over here, this is just the code to check if there are any missing values. There are no missing values in this data set, but for you, there's something for you to get away with because uh, it's quite possible that the data you'll be analyzing in the future has missing values. This is how you check missing values here. It just showing you. Okay? This is just the data frame information. Uh, this one is just showing you the statistics for each column. But again, when I was reading my data, very important, if I didn't read age correctly, then I would see my minimum greater than the maximum, right? Then it's a problem. Or if your mean is greater than the maximum, that is a problem too. Okay? So you want to watch out and make sure that you're reading the data correctly, right? So you did that, you look at this. Then, well, very important thing is, well, first of all, this is a histogram for all columns. You can do one column at a time, but in this case, there are too many columns. So you want to write, sometimes you can write a function that is going to take the whole data frame. It's going to take the list of columns, and it's going to the list of column names, and it's going to take the number of rows in the output, number of columns in the output as an input, and you draw it as a figure. See, you're looping through all of the columns and drawing this plot for each column. See, this is where you are calling, right? You're calling this. See, those columns returns a list of column names. So here you're passing the whole data frame. Here you're passing the you pass the column names. Here it just you have 6 rows and 3 columns in each row. Right? Well, you're not required to do this, but it's an example that I want you to have. Right? Because this session is supposed to add to what's in a classroom. It's not supposed to repeat all in a classroom, so you're gonna have this example. So see, this is a histogram. But still in your paper, you want to theoretically discuss that you would have to look at the histogram, right? Because the histogram, well, you do need to plot something for several columns, because then you would see something like this. See, this is imbalanced, dependent. The target is imbalanced. Why? Well, because see that you have 35,000 rows with no risk, and you only have slightly more than 500 with risk. See? But this is just showing, it's just a shortcut to show the histograms for all of the columns. But keep in mind, if you have some columns that are not numeric, you would have to modify this code to check for the column data type, right? And only do the histogram for numeric columns. Okay. Next thing is that this takes a while to run, but I'm just showing you that it's possible to run the pair price plots, and you need to use this. It's a Seaborn package that you need to Seaborn libraries that you need to use for this example. Okay. Well, this one is it's a correlation. In theory, you want to do correlation because for the a logistic regression. You want to check if the columns are independent from each other. And so is for naive Bayes method. You want to check, are my columns independent from each other? So you're looking at the correlations between two columns. Remember, correlations goes between 1 and -1, right? So, and as you can see, well, see this? This is a number of cigarettes per day. And if somebody is a smoker, see? As I mentioned before, well, see that the correlation is high, right? Well, it shows, it means that probably you want to keep one column or the other, but not both, because of the correlation between those two. And then another one in here, see this prevalent hypertension. And if you scroll down in this position, you have this one, systolic blood pressure. So see this hypertension and a systolic blood pressure, right? So those two are kind of like there is a correlation between those two. So you probably want to keep one and not the other. Same thing here. See this diabetes and the glucose, right? So those two also have the correlation. So you probably want to make sure that your columns that you use in analysis are independent from each other. This is, again, this is theoretical, right? And see this here, what is this? This is diastolic blood pressure, and this is prevalent hypertension, see? Those columns are probably gonna have a correlation, right? Because your blood pressure determines if you have a hypertension, see? So you probably want to use one or the other, depending on what details you're actually interested in. Are you interested if somebody is a smoker, or actually how many cigarettes per day, see? You want to try one, try the other, and see what happens, okay? Well, and this is just going back to parsing data, but this one, this is a bonus. It's not in an example. It's not in a classroom example, but again, this lecture has to add to it. So this is showing the heat map, and you need to Seaborn package, right? In addition to Matplotlib package, those are the packages. You might be wondering why this one is 1. It's because it's a column with itself. Of course, it's going to be 1. Oh, another thing is that here, well, this annotation true, well, what does it do? It shows that I want to see the actual numbers. In addition to just color codes, line width is the width of the line between these two cells. Well, then, the color code, what does it do? It shows the darker the color, the higher is the correlation, right? So the lower is the correlation, rather. So see this here, the lightest one is closer to 1, and you've got the negative. See, in this example, the lowest correlation is minus 0.2. That's the lowest one in this example, but in general, the correlation goes between 1 and -1, okay? The color code shows the correlation strengths, okay? And that's just models, all right? So now let me go back to make sure that I showed everything that's in here. That's a code. I'm just spelling out the details in the code for the histogram plot, right? And I just included the picture here. That's just a correlation, and I'm showing you what you need. Jesus, you need those packages to build the correlation, and you need to make sure that the columns are numeric. If the columns are not, then you want to edit the code and omit them. You want to omit those columns that are not numeric, because it's only for numeric columns, right? That's how the picture looks like. Okay, well, it's also important is that when you submit the work, you have to save the output. You can save it as HTML, then save HTML to print to PDF, or submit the HTML. But very, very important, if you do not submit the notebook here, your work cannot be evaluated, right? You have to show that you actually ran the notebook, etc. Right? And that's just another useful example. What it's doing in there, it's using logistic model to predict if heating and air conditioning system is operational, right? So it's just for you to look at another one. All right. So now I want you guys to ask me questions. Please ask me questions now. Any questions about anything that was discussed? Any concerns that you may have? Anything? Guys, this is a good time to ask questions, or I will start asking questions.
I have a question.
Yes.
Yeah, so let's say we ran the whole notebook. How many hours left do you think that we're gonna have by the time like we finish part 2? Because I know we have to go through it and write the code properly.
Yes, but you can prepare the code before you actually use. Oh, okay. So perhaps part 1 takes about 1 hour, right? Well, let's say 5 hours should be enough for part 2, I think, because if you prepare the code ahead of time, right? And well, I forgot the name. I think it's GoLab, right? There is another editor that you can use actually for the notebook to prepare the code. Or what you could do is take that cell, right? Take that cell where you parse data and carefully plan it. You want to prepare the code and then run it. Only few people turn out of hours, and those are the people who did not follow the instructions, okay? So, well, it depends on the individual. Some people manage to have hours left. But if you run out of hours, you won't be able to finish the work until next month, okay? Next month, you're gonna get 10 hours again. For the next assignment, you will use it just for the R, not for the database work, but for the R work. So that one takes 1 hour. It takes 1. This one takes 1.5, but if you prepare the code ahead of time, you should be good. What code do you need to prepare ahead of time? Mainly it's a parser function, the code that is calling parser function, and then probably the columns that you want to visualize are not the same as the columns in a given example, right? There are a lot of similarities, but still, again, you don't want to be predicting if mother is a smoker. You want to be predicting, in that case, if baby was born underweight, right? Low birth weight, that's a column name that you are predicting, right? So there are 3 parts, right? Part 3 does not require running the notebook. It's a theoretical. Part 2 is a big one, but well, the thing is, what you want to do is when you're done with part 1, immediately please save the notebook, because if you run out of hours, you won't be able to even save the notebook. And trust me, you will not run out if you stop the kernel when you're not running something. Stop the kernel, right? You stop. Then, if you stop the kernel, of course, you make changes to the code, you would need to rerun everything starting from the top. Well, that's important. I cannot just randomly go down and run my last cell. No, you have to run all. Because when you start the new kernel session, right, start new Spark session, you have to redefine, you have to reread the data, you have to redefine all of those variables again. You have to rerun the method again, well, etc., right? So please do yourself a favor and make sure you follow the instructions. But by all means, part one should not take much, because all you do is a credentials block and then a copy the bucket name. That's it. Run it and save it. In fact, it should not even take an hour. It should take less than an hour. All hours should be mainly used for part two. Okay, it's plenty of hours, because you're not going to be running the code for 4 clock hours, right? So just watch out. If you stop the kernel, you'll be good. Then again, deleting the notebook does not stop the kernel. Deleting the project does not stop the kernel. Somebody, I'm not gonna call names, but somebody this semester tried to stop the notebook, the environment, just by deleting the project. No, that's not gonna do that, right? Well, and important, you have to stop the kernel first and then exit the notebook. After that, you can check if the environment is still running. Should not be, but if it does, then you need to stop. But don't attempt to stop the environment in a manage runtime page without actually stopping the kernel. You have to stop the kernel first, see? That's the thing. If you don't, and you have something running, you will be getting an error when you try to delete the environment. So this is something to watch out for. All right? Did I answer the question?
Perfectly. Perfect.
Yes.
Thank you.
Yeah, because it depends on whom, on the person doing the work, right? So and try to do it at the time when you're less likely to be interrupted, right? Because sometimes you get a phone call and you forget about the running kernel, right? Things happen, so just watch out. All right? If you really have to answer the phone, just stop the kernel first. It takes just a second, you know. Any other questions, please? And you all know that discussion of other methods is theoretical. If you have hours left, if you have hours left, you could try naive Bayes method, but that's not required because of the hours. Okay? But a discussion of other methods is theoretical. What you would have done to improve the model performance, this part you have a reading, right? Excellent book, like that book. Then what you want to apply what's in that book to your data. Just discuss, right? Anything else? I'm going to say, Professor Azan, anything you want to add to what I just discussed? Professor Azan, anything you want to add? No? Okay. I take silence as a no. Anything else, guys? Please ask me questions now. It's an opportunity. Okay, so let's see. Chat. How do we use part 1 HTML? Well, okay. How do you do it? Well, you have two options. You can start from brand new notebook, which is hard, or, oh, you mean the HTML? What do you mean? Do you mean the HTML for the, do you mean in general? Sam, do you mean in general, how do you start with part 2, right? You just want to prepare the code first, right? So, well, what you want to do is, first of all, you know that your parser function is going to be different. What you want to do, you copy all of this piece in a maybe Notepad or another notebook editor outside the IBM, right? And you want to prepare, you know that this code cell is going to be different. So perhaps this is what cell 2, right? You take this cell, you take this code, paste in the notepad, and edit it based on your data, right? Take other cells that are going to be different and edit them ahead of time. Then, when you are actually ready to work, right, you take the notebook that you had for part 1, rename it, right, with the name for part 2, upload it, and edit the cells accordingly. You're going to prepare the code, right? Then you just copy and paste. But for this one, for credentials, it's going to be different. Why is it going to be different? Because thesis, that's a different. The file name is different, right? So it's going to be different. What is going to be different? Credentials code will be different. Parser will be different, right? Then you look, scroll down more. Well, code to explore data could be the same. Instead of number of patients, well, maybe number of patients is going to be the same. Then you're looking at this. Okay, well, this is a column name, but the column name, did you look at the count for, is going to be different, right? What are you predicting? It's going to be different, so you prepare the code ahead of time, and then you can just copy paste, right? So you're going to look further, what else is going to be different, and you make those changes. You prepare, and then you just update the code. I hope that helps, right? A lot of stuff is going to be similar, but still parser and the code where you call parser, credential block is going to be different. So you have to make sure that you totally understand what your part 1 is doing before you start working on part 2. Okay? A lot of stuff is same but different. Like, see, this is a column name. I'm looking now at the Framingham, in the Framingham data. See, the column name is going to be different here, right? The column names that you want to visualize. See, there is no education column in the data that you are looking at. Different column. So you want to prepare it, and then you just copy paste everything. For this one, you're just going to have a different number of rows. Very easy to add a row, right? You just copy paste, and then just change the text, right? Does it make sense? Did I answer the question? Okay, I'm glad that I'm glad that I helped. Well, look, there are different ways to do this, different approaches. Okay. Yeah, well, it's not easy. It's not gonna be easy. I understand that, but if it was easy, then what's the point, right? You need to. The point is for you to learn from the assignment, not just get an easy A, right? You want to work for it, right? Because then, what's the purpose of the taking the class? The purpose is to learn, right? So you don't want it to be too easy, because then it's like getting the ticket punched, right? All right, and Professor Ozan, you still here? Anything you want to add? Oh well. Any other questions, guys? I like you to ask, because that's an opportunity to ask. Okay. If there are no questions, then we're gonna call it a night, and I wish you all guys good luck, right? So then I'm gonna stop the recording if no more questions, and I hope everybody does well with this assignment. All right, I'll see you again in a few weeks. We're gonna have another session for DB2 database. Okay, I stop recording and stop sharing.